ശരി ശരി ആയിക്കോട്ടെ ഓക്കെ ശരി ഓക്കെ.
Hello, good afternoon everyone. Welcome to the online classes on soft computing and optimization techniques. Today we will be dealing with optimization techniques, and which will cover fourth and fifth modules, and whatever is left we can complete it meanwhile in the later class. So let me move on to the class. So let us see the basic overview of optimization techniques. So a basic overview of optimization techniques is provided. The standard form of general nonlinear constrained optimization problem is presented, and various techniques for solving the resulting optimization problem are discussed. The techniques are classified as either local, that is typically gradient based, or global, typically non-gradient based or otherwise called as evolutionary algorithms. So let us first see what is meant by local algorithms. So as I mentioned, there are two types of techniques. One is local or otherwise called as gradient based algorithms, and there is global, which is typically a non-gradient based or otherwise called as evolutionary algorithms. So first we will see local algorithms. So here local algorithms, these are gradient based algorithms, and global algorithms, these are actually non-gradient based algorithms. Or again we can see that the optimization involves techniques like used in evolutionary algorithms and global optimization. So before we start a review of the available optimization techniques, it is useful to present the standard form of general optimization problem that will be solved by these techniques. So let us see what is meant by a general optimization problem. So the standard form of a single objective non-linear constrained optimization problem is shown below. Minimize f of x subject to gj of x less than or equal to 0 for j is equal to 1 comma m, hk of x equal to 0 for k equal to 1 comma p, and xi l less than or equal to xi less than or equal to xi u, I equal to 1 comma n. So as we see, this is the standard form of for a single objective non-linear constrained optimization problem. And here actually we will later on see what are the terms meant by objective function and what is meant by constrained optimization. So here in equation 1, this equation, let us mark this as equation number 1. So this is equation number 1. Okay. So in equation number 1 represents the objective or goal function. So here something called as the objective or the goal function, so which is represented by f of x. So f of x is the objective or the goal function. Then gj of x an inequality constraint, and hx of x is an equality constraint function. So here gj of x, as you can see here, gj of x is less than or equal to 0 is the inequality constraint, and hx of x, sorry, hk of x, it's not hx, it's hk of x is an equality constraint function. Okay. So there are constraints, two constraints. One is inequality constraints given by hk of x, and equality constraint function, sorry, gj of x, which is an inequality constraint function, and hk of x, which is an equality constraint function. The vector x represents the n design variables that are modified to obtain the optimum. Okay. So here let us treat this x as a vector, and the x vector represent the n design variables that are modified to obtain the optimum. Okay. So here you can see function of x, gj of x, hk of x, and what this x implies, and we are having the constraints xil and xiu, and we can have the constraints in between xil and xiu, and here actually x denotes a vector which represents n design variables and which can be modified to obtain the optimum. The searchable design space is defined by the upper and lower bounds, that is xil and xiu as shown in the equation, xil and xiu of the design variables, and is referred to as the site constraints, and these are the site constraints other than the equality and inequality constraints. So, other constraints which are apart from equality inequality constraints are called the side constraints. So, constraints it's a limit. There's a limit to which a particular input can be or given, or we can say a particular change can be made. So, here അതിനുള്ള ലോവർ ബൗണ്ട് എന്ന് പറയുന്നത് XIL അപ്പർ ബൗണ്ട് എന്ന് പറയുന്നത് XIU ആണ്. ലേറ്റർ ഓൺ നമുക്ക് ഒരു ടിപ്പിക്കൽ ഒരു എക്സാമ്പിൾ നിന്ന് നമുക്ക് മനസ്സിലാവും എന്താണ് ഇവിടെ കൺസ്ട്രെയിൻസ് എന്ന് ഉദ്ദേശിക്കുന്നത്, എന്താണ് അവിടെ സെറ്റ് ചെയ്യേണ്ട ലിമിറ്റ് എന്താണെന്നുള്ളത് നമുക്ക് മനസ്സിലാവും. In the general case, the objective and constraint functions can be linear or non-linear and can be explicit or implicit functions. So, here in the general case, we may say that the objective and constraint function. So, here objective means the objective function, and the constraint function can be linear and it can also be non-linear and can be explicit or implicit function. So, here in meaning of implicit is inbuilt, okay, explicit or implicit functions. So, implicit functions commonly appear when, for example, a numerical simulation, example a finite element simulation is used to evaluate the response function, example stress value. Also, the design variables need not be continuous. So, what do you mean by implicit function? We can take an example, we can quote an example. So, an example is a numerical simulation. We have a numerical simulation. So, example we have a finite element simulation, and in which we use to evaluate, in which is used to evaluate a response function. There is a response function, something like stress value. Stress value is an example of a response function, and also the design variables need not be continuous. Here the design variables need not be continuous. Optimization problems having some or all of the design variables restricted to integer or discrete values are not uncommon and are referred to as integer or discrete optimization problems. So, there are several problems in which we come across discrete or continuous values. So, optimization will be dependent upon the design variables, and which could be restricted to integer or discrete values, and such a case or such a condition where the design variables is restricted to integer or discrete values is referred to as integer or discrete optimization problems. So, generally the local algorithms have difficulty in solving optimization problems with integer or discrete variables, while several global algorithms are well adapted to this class of problems. So, as you have seen that earlier we have discussed about two types of algorithms. So, which are the local algorithms. So, these are the local algorithms and the global algorithms, and here we require the constraints actually depend upon whether we are dealing with a local algorithm or a global algorithm. So, here generally the local algorithms have difficulty in solving optimization problems with integer or discrete variables, while global algorithms are well adapted to this class of problems. So, where it is difficult to solve using local algorithms, we have to use global algorithms, and a certain class of problem where it is difficult to solve using local algorithms can be solved by global algorithms. Most optimization algorithms consider the side constraints separately from equality and inequality constraints. So, as I have told earlier, other than equality and inequality constraints, we have what is called as the side constraints. So, these are apart and separate from equality and inequality constraints. So actually here the meaning of constraint is to set a limit. There is a limit, and we will understand what is the limit or what is meant by constraint by quoting an example. So before going to the example, let us see the conditions, the features here. The site constraint can be handled efficiently by direct implementation in the algorithm. So can be handled efficiently by direct implementation in the algorithms. So regarding this is said regarding the site constraint, and here can be handled efficiently by direct implementation in the algorithm. A good algorithm will never violate any of the site constraints. So dealing with local algorithm or global algorithm, and here we say that a good algorithm will never violate any of the site constraints. So that means the site constraints will be accounted and that will be taken into consideration. An unconstrained optimization problem thus has no equality or inequality constraints but may have site constraints. So there is another condition where we have an unconstrained optimization problem. So there are no constraints, and if at all there are no constraints such as equality or inequality constraints, we have site constraints. So even though there are no equality or inequality constraints, we have site constraints. So a constrained optimization problem has one or more equality or inequality constraints with or without site constraints. So a constrained optimization problem is one which has one or more equality or inequality constraints with or without site constraints. So it may have site constraints or it may not have site constraints. Anyway, a constrained optimization problem has one or more equality or inequality constraints. For a constrained optimization problem, an equality constraints can either be violated or satisfied, while an inequality constraints can be violated, active or satisfied. So here as far as constrained optimization problem is concerned, an equality constraint can be either violated, the constraint എന്ന് പറയുന്നത് മറികടക്കാം, അത് വയലേറ്റ് ചെയ്യാം, or it can be satisfied, അത് സാറ്റിസ്ഫൈ ചെയ്തെന്ന് വരാം, ആ ലിമിറ്റിൽ നിന്നുകൊണ്ട് constraint ലിമിറ്റിൽ വിത്തിൻ constraint ലിമിറ്റിൽ സാറ്റിസ്ഫൈ ചെയ്യാം. While an inequality constraints can be violated, അതേസമയം ഒരു ഇനീക്വാലിറ്റി കൺസ്ട്രെയിൻ്റെ കേസിൽ അത് വയലേറ്റ് ചെയ്യപ്പെടാം. ആക്റ്റീവ് ഓർ സാറ്റിസ്ഫൈഡ്, അത് ആക്റ്റീവ് ആയിരിക്കും, അതായത് ആക്റ്റീവ് കണ്ടീഷനിലായിരിക്കാം, അല്ലെങ്കിൽ അത് സാറ്റിസ്ഫൈഡ് ആയിരിക്കാം. An active inequality constraint is one for which Gj of x equal to 0. So in the earlier equation we have defined this Gj of x, and we have the conditions Gj of x less than or equal to 0. So when Gj of x is equal to 0, we called this condition is taken here as an active inequality constraint. It is an active inequality constraint where we have Gj of x equal to 0. And here regarding the variable Gj of x is an inequality constraint, and whereas hx or hk of x is an equality constraint function. Okay. So moving on, optimization techniques or algorithms are used to find solution to the problems specified in equation 1. So actually we have already discussed about equation number 1, and these are the limits. We can see the limits here, or these are the constraints, otherwise called as the constraints. And also we have the constraints or the constraint limits here, and regarding the equality constraint and inequality constraints, we have already the variables Gj of x, which stands for inequality constraints, hk of x, which are the equality constraints. The procedure consists of finding the combination of design variable values that results in the best objective function value. So we have the objective function value which is already defined by f of x. So here f of x is the objective function value, and these are the constraint functions. So whereas gj of x and hk of x are the inequality and equality constraint function respectively. So here the procedure consists of finding the combination of design variable values. So ഇവിടെ design variable values കണ്ടുപിടിക്കുക എന്നുള്ളതാണ്. That results in the best objective function value, that is f of x, the best objective function value f of x, while satisfying all the equality and inequality side constraints. And this should be satisfying the equality, the inequality, and the side constraints. As you can see here, the constraints are given by xil less than or equal to xi less than or equal to xiu, and the function, the equality constraint also defined by the constraint functions gj of x less than or equal to 0 and hx of x less equal to 0. And here the side constraints can be defined here according to the fourth equation. So there are many options for classifying available optimization techniques, and a short overview of the available algorithms using a broad classification as either local or global algorithms is presented. So we are discussing firstly about local algorithms, then we will discuss about global algorithms. So what is meant by local optimization algorithm? So here most of the local optimization algorithms are gradient based. So the gradient based algorithms are called as local optimization algorithm. As indicated by the name, gradient based optimization techniques make use of gradient information to find the optimum solution of equation 1. So we are once again referring to equation number 1, and we are going to find an optimum solution to equation number 1. So here as indicated by the name, so the name is actually local optimization. So it's a gradient based, it's a gradient based optimization technique which makes use of gradient information. So it's using a gradient information. Actually, as you know, the gradient is a function, which means a change here. So a function which is dependent upon a change to find the optimum solution, and it finds an optimal solution. Gradient based algorithms are widely used for solving a variety of optimization problems in engineering. So actually gradient based methods or gradient based algorithms are widely used to solve a variety of optimization problems in engineering. Okay. I'm sorry, stream break ആയെന്നൊരു ഡൗട്ട് ഉണ്ട്. ജസ്റ്റ് ഞാനൊന്ന് നോക്കിക്കോട്ടെ. Okay, I'll be talking something just to check whether the stream is okay, and please hang on. Yes.